Hi, you're welcome once again to this class. I'm going to continue with what I started last class, which is NumPy, which is we are still in AI series. So we're going to do extensive class on extensive classes on NumPy. So we're going to get it all many things around it because these are the building blocks of AI, artificial intelligence, like machine learning and deep learning. These are the building blocks. That's why we are trying to trash out this understanding. Okay, so we are going to look at the different dimensions right now. So yesterday I spoke about NumPy being able to attend or address or handle numerical values. That's why they call it NumPy, which is numerical Python, right? Or numeric Python. So we use it to handle several dimensions. Today we are going to look at the various dimensions, and then how do we know the dimensions they belong? When they give you a number or series of number or collections of number, how do you know the dimensions it belongs? Because in the world we are trying to, most of the things we are dealing with, like most of the data we are dealing with, they are of different dimensions. When I say data, I mean text. They could be in form of text, they could be in form of image, they could be in form of video, they could be in form of audio. These are all data that could be accessed, manipulated, or not analyzed. So in such a case, we need package like this, like NumPy, which is a Python package that helps to handle numeric values and also the operations, arithmetic operations on or algebraic operations on those numeric value. So let us proceed right now. So the first one I'm going to do, the first thing you do first, I've told you, you install NumPy, then you import it. So we're going to move away from there. Now, I want to first of all do, let me just put a comment here. So the zero dimensions, now this one is without dimensions. So the dimension is just a single value. That means no dimension. Let me call it zero dimension. So this dimensional. So this one has no value. Has no dimension, but it's just a scalar value. We call it scalar value because there's no dimension. Now, if you check now, if I want to do it, you say NumPy that MP. You can still do it like this. You can still do NumPy. You can still import NumPy and say NumPy. NumPy is the array function or array method of it that you use. You see, like this. But if you don't want to do that, you can rename this one using as NP. So you can just have this one like this, MP now, MP. Okay. So if you put your zero, any number here like five, now. This is a single value, whether it's 42. These are just single value, like the number counting value we know. So those are scalar. They are not having any dimensions. It's just a number. Like you say, okay, say the magnitude of something. In physics, we say magnitude. So there's no direction, for instance. So there's the definition of direction is not part of it. So in this case now, single value, they are called zero dimension. So that's what I'm doing right now. So let me just store it. This is a variable. If you have done Python before, you know that you can name it any variable. Like I'm storing it into data. So let me print data now. Let me print data. I'm just printing to display what is there. So there's no. So if you want to check, okay, so it's running there. You will see my cursor at the hourglass. We call it hourglass at the top. It shows that it's running. So it's going to give me the value. It's going to process. So it's start 42 now. So if you want to check the kind of dimension it belongs to, you are going to use stuff something to know it. Like you're going to name it as n dime. You understand? N dime. So you can know it. I have reference materials like yeah, just put n dime, you see it there. So let me just show you. Yeah, something like this. Can you see n dime? And n could mean anything. You understand? N could mean, sorry, n could mean 2 3, but n dime means it's gonna show you which kind of dimension. So let's check the kind of dimension it belongs to. So let me print it again. You can just do like this. If you don't want to use print, you can say n dime. Sorry, n dime. Okay, so let me just run that one. You see, it's going to give me 0. Yeah, the output is 0. Okay, so if you don't want to do that, you can still use print too. You can still use print, and then just so you see now it's giving me stuff like this. Okay, so I'm going to be showing you several dimensions and how to know their dimensions. So we have done 0 dimension, which is just a single value. So the next one is the 1 dimension. Let's do 1 dimension now. So let's call it, let me comment here, 1 dimension. So 1 dimension in this case now, If you want to do more one dimension, let me just create the list so you know that this is let me call it list. Let me just say 0. That is, I'm just do like this equals to. So the first one, let me just say all the even number 4, 6, 8, 10. Let me just do 5 values there. So this is a single dimension. You can see it like a linear stuff, single dimension. It doesn't have rows and column. It's just like a row. Even though it's like a column too, fine. Like if you have something like this, let's say list 1 equals to, begin up like a row now. I mean, just single stuff, yeah. So 1, something like this, to like a kind of column. I mean, that's what I'm saying. So they are all in mathematics. We have something like that. So they are all single dimensions or single or one dimension. So if I have something like this now, I put it inside. I put it inside the NP array. Let me just call it. Let me just name the data 1 now. Let me just say NP. I'm stepping in data 1. So NP, the same thing we did before. So this is a method. So inside it now, let me put the list. You can still do the list inside. You can say, okay, let me do the list inside, which is 2, 4. But I'm not doing that. I want my work to be very neat. So I put the list inside now. So this list now, if I print the data 1 now, you see that I get these things out. This is an array, or it's a list, which is a NumPy array. So let me just find the dimension now. So if you want to find the dimension, just say data 1. I'm showing you how do you understand one dimension, 0 dimension, 1 dimension, like that. So n dime, don't forget n dime. So if I print this one now, let's see what it gives us. It's showing us 1 now. So that's the 1 dimension. So let's move to the next area, the next one, which is 2 dimension. So I need to show you how it goes. Let me quickly show you a diagram here. So this is, you see, this is a single dimension. It's 1D array or 1D tensor, if you like. The other one is 0D tensor, 0 dimension tensor. So now this one is 2 dimension. So it has a row and it has a column. You understand? This is row, this is column, this axis. The first in don't forget, I'm going to say this one right now. This is, if you let me zoom it big. Let me see if I can zoom it big. Okay, so this diagram is very important. So this axis 0, this is axis 1. Take note. But this axis 0 is also your column, which is your y-axis. If you like, you can call it y-axis. This axis 1 is your x-axis. So you in 3D now, you have axis 0, axis 1, axis 2. You understand? It's just as if you are going anti-clockwise, for instance. Okay, so we'll come back to axis later, but just understand this. Very, very key, very important. It's going to help us in advanced aspect of this course. Okay, now we're going to proceed back. So I just want to show you this one. This is 2-dimensional array. That's column. That's column, it has row. So let's look at it again. So let's come back to our Jupyter notebook. So this is it. So let me call it list 2, or let me just comment here 2D array. So in this case now, let me just call it list 2. So if you want to get that now, it's going to be something like this. Take note of that now. So it's rows, column, like that. So if I have something like this, let me just say 2, or let me just say 1, 3. Let me do even number and even, I mean odd number and even number. So 5, 7, 9. Okay, there are about 5 numbers. Okay, now if you are doing stuff like this, so you have the other one again. You understand? Because it's supposed to be like this, like something like this now. So 2, 4, 6, 8, 10, something like this. That is, this one is another. In computing, you can't arrange it like what you are seeing in that picture. You can't, like what you are seeing in this picture. It can't. This is a picture image. So, but in computing, when you're trying to type it, when you're trying to type it, it looks like it just has to be like this. But there's a comma here. But at the end, you can put a array. Something to cover the entire, because array must have a square bracket that covers everything. So if you have something like this, but if you like, you see, I do it like this so that you can look at it as a kind of rectangle. But sometimes you can see people doing it like this. But if I do it like this, you won't understand. You'll be seeing what it means. So that's why I leave it like this. So it's much more you can visualize it. You understand? So let's look at it now. So let me just print it out. Let me do mp now. Mp dot array. Oh, sorry, I'm using capital letter. I like to use small letter. Mp dot array. So let me push that list 2 inside. Then if I push it inside, I can still store it in data 2 now. Let me just call it data 2. So I want to store it inside this array. So if I run it, if I print it out, maybe I can print like this. Okay, let me just print data 2 out. Just print it and see what it gives me. You see now the way it's arranged. Now without check the dimensions right now. So this is it. But you can say data 2 now. Let me just say data 2 dot end-time. So if I end-time, so if I run it, you see that it's going to show me that it's 2-dimensional. So this gave me a tough time during those days when I was started learning, trying to understand how you use these things even in advanced machine learning. Okay, so it was giving me some tough time trying to understand, because possibly the kind of concept we have about those things was not clear before. So I have to do research into it. Now let's move to 3-dimension, which is where I'm going to stop. So let me just put a comment here. 3D array. Let me call it 3D array, or 3D tensor if you like. So how do you do it? So let me take you back to this place. So if you have this one now, let's take this place. This surface is one, just like you are combining 2D, several 2Ds. This 1 2D, this surface. The next surface is inside. The next surface is inside. So I just want to do only this because you can do more surface like that, but let me just open this particular two surface, this one and this one. Okay, so that means it's going to be like 2D and 2D. There's one stack, the other that is stacked behind it. There's this one is stacked behind the surface. Okay, so let's look at how you do it now. Okay, so let's look at it now. So let me call it the data 3, or yeah, data 3. So this is how you do it. You are going to do, let me just do even number like that. So the first thing is this: you have 2 dimensions. That means we are doing 2 dimensions now. Stack, another 2-dimension stack. That is how it is. So these are the 2 dimensions. You can just copy this one and put there, but let me just do it for you. So let me first of all do the 2 dimensions now. One, this single dimension is like, if you let me come back again, like the single dimension now. Single dimension, 2 dimension is the build up. If you build on this 1 dimension, you just like this one and this one, so form 2 dimension. 2 dimension is take this surface now, build another stuff which is at the surface. So you can see that they are the building blocks. Like the building block, 2D is a building block. When you build 1D, you can build it to 2D. 2D can be built to 3D. So you can see that they are just a kind of offshoot. So let's look at it now. I'm always minimizing. So you have this now. So let me just say 3, 5, 7, 9. Okay, this is just one single dimension. So if you want to make it to the dimension to be 2, 4, 6, 8, 10. Okay, so this one will be 2 dimension. This is 2 dimension now. So we know the way I did it before. So let me just put it like this. Okay, then I'll put a bracket it together. Brackets, yeah. So let me just bracket together. Oh, sorry, bracket. Then this bracket. That's how I do 2 dimension. Now, if you are moving to 3 dimension, you have to. You understand? So it's 2 dimension combined together. So let me just now make this place. Let me just say that's after this dimension now. I've closed it with the bracket now because I'm added 2 dimension. So let me just have the as let me just say 4. Let me have another one again. 4, 8, 12, 16, 20. Okay, so I'm doing on this dimension now. Another 2 dimension, I'll combine it. So which is this one will now be what? Let me just do 5, 10, 15, 20, 25, 55 value. I'm doing it to 25. You can put any value. I'm just 20. And what? 25. So after I've done it, so let me just group this one now. Group this one. I've grouped it now. So if you check this one ended here. You understand? Then this one This is another two dimension which ended here. Now I can now group all of them together. Group all of them together. Okay, can group all of them together. I'm just trying to build it so that you understand, because it's sometimes difficult to visualize in when you're compiling it or computing it. Okay, so we have done these three dimensions. So let's put it here now. And let me just say np dot what dot okay, let me print it, or I can print it. So this is there are stuff now. So let me just do this and see. So you can print it if you like, don't print it, any of them, but let me just print it and see. So if I print it now, it's gonna be I don't want to use print. So let me just say np dot what array. So put it into the array. You have data 3. It's not compulsory you always print it like this, but so I this 3 dimension actually. So but let me just do this in end time so you see it better. So if you check now, you see, oh sorry, I'm doing the other one. So data 3, right? Okay, so if you check it now, oh shit. So wait, let me come to this. Let's say list as not attribute. What am I doing? Data 3, right? Okay, end dime. What is the problem? End dime. It said list object has no attribute. Okay, maybe I have to, let me equate this one. Let me just say data 3. Okay, let me just equate it here. So let me remove this stuff, because sometimes you have to treat it as a NumPy array. So let me run it again. Let me run this one first. Okay, let me run this one and see. So, okay, so what I did is that I have to convert it. To NumPy array, not just normal list. Normal list in Python doesn't. So I have to convert it to NumPy array. It has to be converted to NumPy array before you can use end-dime. Is that clear now? So this normal list, like without putting NP array, doesn't convert it to NumPy array. You understand? This is normal our list. But if we put it here now and put it there, we save it here. This the data 3 now becomes an the kind of list that is NumPy list. Let me put it that way, or NumPy array. So it's NumPy array now. You can do end-dime. So that's why it gives us 3-dimensional. So you can see I'm arranging. You can also do 4. I don't know, 4-dimension. Maybe you can be able to visualize it 5-dimension. That's cool. That could be very advanced and high. These are advanced tensors. So this is how you can do your end-dime and use it to check which dimension stuff belong to. We're going to be using this in image analysis, video analysis, like that. This in our later course. That's why we need to just have this understanding of this foundation. Okay. So we're going to stop here for today. I know the video is a little bit prolonged because of I just need to clear this particular stuff. Thank you very much and have a wonderful day. I see you tomorrow.